Alright, Math 3, Practice 3.1.2, the unit circle. So, we talked about earlier, these radians, we like to use them with what we're doing now. And this unit circle concept is going to help us. So, just a reminder, the basic idea of the unit circle is, if we took a coordinate plane and we drew a circle on it. Now, if this circle, and my circle obviously is drawn symmetrically exact, but it goes, these points here, x and y intercepts, are 1s. So that'd be 1, 0 for a coordinate, negative 0, negative 1, 0, positive 1, and negative 1, 0. Okay? That's our unit circle when we're thinking about it. Okay? We make it the radius a 1, the smallest possible, that is easy to deal with. Okay? Now, when we're talking about the radian measure on the unit circle, okay, here's the best way to do it, because when they give it to us in radians, I think, honestly, let me draw that back. I think most of us are pretty good at saying, okay, that's going to be 90 degrees, that's going to be 180, halfway around, that'll be 270, that'll be 360. Okay, and I could keep going around and keep adding those numbers to it. If I cut 90 in half, that would be 45. If I cut this one in half, it ends up being 135, and so on and so forth. And I can cut them into thirds and fourths and fifths, and I can keep cutting them up, and we would know a lot of those degrees. Well, with radians, it's the same kind of idea, and here's the best way to do it. Okay, first thing we need to remember is in the circle, okay, halfway is pi. That's 0 still. Halfway, if we start here and go around halfway, that's called pi. Now, if we keep going around again, back to 0, that's also called 2 pi. Okay? So we've got that basic idea. So if I told you to measure a radian of pi, you would measure 180 degrees. Same thing. Okay? Half a circle. So now, what about when we get this fraction? Okay, well, the way to think about it is this. Pi is like 1 over 1. We have one section, and we went that one section. What if I have pi over 2? Okay, 1 pi over 2, or 1/2 pi. Well, half of 1 would cut this in half, and we'd make 2 pieces, and we only have one of them. So my angle would go to right there. Okay, what if I decided to make this 2 a 3? So I would cut this into thirds, and then I would say, okay, if I have one of those thirds, I go here. What if I had 2 thirds, 2 pi thirds? Well, I'd go right here. 3 pi thirds would be 1, 2, 3. 3 of those pieces. Okay, so this is the best way that I can think of to explain it. So what we need to do is that bottom number. First thing we always need to remember is that we're only dealing with 1 full pi is only half a circle. If we double it, that's when it's the full circle. Okay, so we're not dealing with a full circle when we just talk about pi. So I look at the bottom of my fraction, 9. I need to cut this up into 9 pieces. Okay, so the best way to do that is to see thirds, and then I cut each of those thirds into thirds. Okay, and they're not going to be drawn to scale, but that doesn't matter. So I've got 1 piece, 2 piece, 3, 4, 5, 6, 7, 8, 9. Now, the top number, my numerator, next to pi, tells me how many of those slices I'm going. I'm going 2 of them. So, 1, 2. So my angle then, my angle measure starts right here, and it goes up right to here. That's my angle measure for 2 pi ninths. Okay? Now, what if we switch things up like this? 8 over 5. Now, 8 is going to be bigger than 1. So my angle is going to start here and go all the way down somewhere here. But I need to split it up into fifths. Now, that doesn't mean I split the whole circle up. I still split only half into fifths. So let me grab a different color. So if I did fifths, I'm just going to kind of eyeball it here, so something like that. So we have 1, 2, 3, 4, 5. Then I'm going to do the same thing down here, cut it the same way. Okay, 6, 7, 8. So if I start right here for number 2, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, and end right here. Here's my angle. From here, clear around to there. Okay, can we overlap one more on this? So this was number 1, number 2, so number 3, let me get another color, brown. So now my bottom is 6, so I need to split it into sixths. So we need to kind of do with the thirds, but cut the thirds in half. So if I cut it into thirds right here, about right there, and then I cut those in half, that would give me 6. And once again, not drawn to scale. So 1, 2, 3, 4, 5, and 6. This would be the last one to the 6th. Okay, but I'm only going to 5 of them. So I start here, and I go 1, 2, 3, 4, 5, and end right there. So that blue angle would be 5 pi 6 radians. Okay, now could we convert them to degrees and do the same thing? Yeah, you bet you could. But I honestly think this is easier when you realize that the bottom of the fraction is how many pieces in half of the unit circle, the top number, how many of those pieces were actually taken. Okay? Now, for 4 through 7, it wants us to find reference angles. The way to think about a reference angle is, okay, so we've got the unit circle here, thinking about it as just one quadrant, essentially. Okay? One quadrant where we go from 0 to 90. Now, on the other side, we think of it from, 0 up to 90 as well. So it's kind of just, if we were to get a smaller piece, a reference angle is just the most basic part if we're just thinking about half of that. Okay? So like 15 degrees, here's an example. If we did, what am I thinking of? Okay, an angle that was 45 degrees. Okay, would go to right there. Okay, what if I did an angle that was 315, which is actually close to the one we're doing. So 315 would go 90, 180, 270, 270 plus 45 would give me 315, would be this angle around like this. But its reference angle would be just in this little quadrant, it would be a 45 degree angle. It's just going down. Okay, but these two angles are the same angle just from this vantage point if we think about just going up or down. That's kind of what it means by reference point. So for 318, okay, so we'd go around and right about a little more than halfway. So I'd go 360 minus 318. Okay, that's probably going to be our easiest way to do it because that's that distance here. So we'd get 2, be 4, so 42. So 42 degrees would be the reference angle. Now, what if we have radians? That's fine too. Okay, in radians, we can find those as well. So 4 pi fifths, we change it to, oh, that was horrible, that last one. 5, okay. So we've got 5 pieces, so 4 pi fifths would go 1, 2, 3, 4. Okay, so it'd be the angle right here. Well, its reference angle would be this section right here, which would be 1 pi over 5, right? Because it would just be going one piece. So we would just say pi over 5 would be its reference angle. Now, if I wanted to figure it out in degrees, I'd go 180 over pi. Those pi's would cancel. 180 divided by 5 would be 15. No, 35. 36. So its reference angle is pi fifths, or 36. Now, usually if we're doing something in radians, we keep it in radians. So its answer would be in radians. And if we're doing something in degrees, its answer is in degrees. Alright, number 6, pi thirds. Well, that should be a fairly easy one actually, because we'd cut this into thirds. 1, 2, 3. One of those thirds would go right here, which is in that quadrant, so it would just be pi thirds. So its reference angle is pi thirds. Now, number 7 throws us off a bit. It says 4.087 radians. Okay, this one's a little bit harder, because we have to remember, as we go around the circle, that's pi, that's 2 pi. If we keep going, that's 3 pi, and 4 pi, and so on. Okay, so 4.087, if I go 2 times pi, that's 6.28. Okay, that's too big. Regular pi we know is just 3.14. So it's somewhere in this zone. Okay, that it would come. It would start here and go around somewhere about here. Okay, so what I'd want to do is go 4.087 and subtract 3.14 from that. Okay, because doing that's going to help me figure it out a little better. Okay, so it would be 0.947, which, if we cut 3.14 in half for a 90 degrees, that's bigger than 0.947, so it would be 0.947 radians is our reference angle. If we really wanted to, we could go 947 times 180 divided by pi to put it in degrees to give us some sort of idea, but we can leave it like that. Now let's see what we'd get though. 0.947 times 180 divided by pi. That gives us about 54.26 degrees. Okay. Yeah. Alright, 8, 9, and 10 says find the coordinates of the point where the terminal side of the angle intersects the unit circle. Round each coordinate to the nearest hundredth. So now we're getting even trickier. Okay, now we're saying, knowing that for our unit circle, this point is 1, 0, 0, 1. And this is building into stuff that we'll do later. Negative 1, 0, and 0, negative 1. So now, if we take this, and we graph it, 5 pi over 4, so 1, 2, 3, 4, 5. So 5 pi over 4 would start right here. The angle would come around till it got to there. Okay, so with that angle, 5 pi over 4, okay, it wants to know what would this point be. Okay, so how do we figure that out? Well, this is how. So what we end up making here, we drop this point down to the x-axis, okay, and this point, right? So this point would be something x, something y. So the x distance is measured on the x-axis, or the horizontal, the y on the y. Now, what did we just create? Hopefully you can see it. It's a right triangle. This is x, this is y. Okay, do we know the hypotenuse? Yes, we do. Because the unit circle has a radius of 1, I know that the hypotenuse is 1. Okay? Can I figure out that angle? Yes, I can. It's 5 pi over 4. Okay? What can we use to connect this to these two numbers? Well, instead of calling this x, why don't we call this the adjacent? And instead of y, we can call this one opposite, and this the hypotenuse. So we can use trig, and this is our theta. So thinking of SOHCAHTOA, what connects the adjacent side to my angle? Adjacent would be cosine when we're given the hypotenuse. So I'd go the cosine of 5 pi over 4 is going to be equal to the adjacent side, x over 1. So basically I just multiply this, cosine 5 pi over 4, that's going to give me x. Similarly for the y, the opposite ends up being the sine of 5 pi over 4, the so equals x over, or y over 1. Okay, over 1 really doesn't do anything, so that would be for the y value. So let's get a calculator out and see what they are. It says round to the nearest hundredth, so that's 2 places. So for the cosine, we get negative 0.707. Rounded to the nearest hundredth would be, for the x value here, negative 0.71. Then we do it for the y value. So I type in sine of 5 pi over 4. And interestingly enough, we actually get the same thing, so negative 0.71 for that one. So the coordinate for this one, so this point right here on the unit circle coordinate is negative 0.71, negative 0.71. Okay, so now we got to do that whole same thing for pi over 6. So if you remember pi over 6, we would actually cut these into thirds. So, oh, that was a horrible job doing thirds, wasn't it? Let's try that again, better. So then to make them into 6, I cut those in half. We've got 6. Now we only want one of them. So 1 pi to 6 would be just that first one, right? So there's my angle right there. There's my point. So once again, it makes a right triangle with x here, y here, my angle of pi sixths here, and a radius of 1. So to find that point again, that's the x and the y. So the opposite over the hypotenuse, so the cosine, actually sine, of pi over 6 would equal y over 1. And the cosine of pi over 6 would equal x over 1. So I do what the cosine of pi over 6 is to get x. And we get 0.866, which we round to the nearest hundredth like it told us. And we get 0.87. Then we do it for y. Same thing. So I do sine of pi over 6. And for this one we get 0.5. So 0.5. So we get 0.87.5. That's our coordinate right here. Alright, so that would be the answer to number 9. Now we finally do the last one, 2.834. Okay. So once again, we draw this. Okay. Half of a circle is 3.14. So 2.83 won't quite go halfway, will it? It'll be somewhere around there. So that point. Okay. Now, to get this reference angle, because we want this angle, not the outside of the triangle, we want the inside. This is the 2.834 radians. We need this part, okay, to be able to use the trig, right, the x and the y, the x and the y. So once again, it'd be the cosine of whatever this question mark angle is equals y over x over 1, I mean, and the sine of whatever that is would equal y over 1. So to figure that out, we just go 3.14 minus 2.834. So that would be 3, so we get 6, 0, 3.306. Okay. So that's what we put into our question marks. 0.306. 0.306. And we get for the x value 0.95. Then we do it for the, oh, that was the x value, wasn't it? Okay, now we should remember that since this is going to the left, it should probably actually be a negative 0.95 for that point, right? So we're thinking of the coordinate, that's on the negative x. The y, however, will be positive. And we get 0.30 for the y when we plug that into a calculator. So kind of a weird way to do it, but that's how it goes. So there we go.